So we're really happy to have you here, all the way from Hawaii, right? And this is really a meetup group. We're eager to learn. There's a lot of companies dealing with automotive here in Gothenburg, of course. So that's a special interest. So we would like just to learn a lot this evening. So it's really up to you how to spend the time here. We prepared some questions, and the scene is yours.
You're very kind. You're very kind. The shortest of introduction. Hello, I'm Joe Justice. I worked in Tesla. I did operate Agile at Tesla for Elon Musk. So I'm an enormous fan of Gothenburg, of Sweden, and of Scandinavia in general. Also, when you measure power distance, if a new employee sees a critical problem in a company, maybe something unethical or a direction that's going counter to climate action, how likely are they to say, I think there's a problem? If you have a high power distance country like Vietnam, India, Japan, it's not polite for you to talk to your boss about a problem. And it's extremely unpolite to talk to your boss's boss. And in fact, about anything, even a compliment. You don't talk to your boss's boss. It's rude. It's extremely rude. Well, in Sweden and Finland and Norway and Denmark, those are measured to be some of the lowest power distance cultures in the world, in the whole world. When you have a new employee, their confidence level to talk to their boss or boss's boss, or even walk up to the CEO and say, I think we have an ethical problem here. I think we're doing something incorrect about a climate future that's good for the world. They probably won't be fired in Sweden. In fact, they might even be welcomed. That is unusual in the world. That is beautiful in the world. And it's no wonder that some of these collaborative group work styles of working, like Agile, like Mob, are so relatively easy in Sweden and Finland and Norway and Denmark. Okay, so a little bit more about me. When I was working in Tesla, we did a lot of Mob or ensemble work. In fact, we did everything in Mob and ensemble work. Before working in Tesla, I did consult for the leadership team at Amazon. So I did work for Jeff Bezos. And I learned some things about Jeff Bezos's leadership style at Amazon. And before that, I did work directly with Bill Gates. I was using an older form of agility then that was more than 10 years ago. I used something called Scrum. I was something called a Scrum Master on a team with Bill Gates. I'm sure if I worked with Bill now, we wouldn't use Scrum. We'd use a more modern Agile framework. But at the time, it was perfect for our purposes. So I have worked directly with Bill Gates. I've worked for Jeff Bezos, and I've worked for Elon Musk. And a common question is, what are the pros and cons of each, or how would you compare their leadership styles and tactics and what works for each of them? So I'll try to talk about that. But now you have a little bit of an introduction to me. You know a little bit about why I'm so happy to get up early in the morning. I'm typically paid thousands and thousands of euro to consult per hour to a company like Einride or Saab. And I'm joining this at no cost because I'm very passionate about what Sweden and Gothenburg is likely to bring our climate future and our work future. So I hope you know why I'm here and why I think you're really cool and who I am. And now let's go to Q&A. What is important for hardware agility and quick feedback loops when it comes to suppliers? What I think I learned in Tesla. First, Tesla is arguably the most successful company working with suppliers globally. They work with traditional suppliers like Bosch in Germany, and they work with startup suppliers that no one had heard of yet. They work with multi-year lead time suppliers where you decide years in advance what you're going to get. And they work with suppliers that will make something new for you that day. what is the result of this? There's something called the chip shortage in American English all across automotive manufacture and all manufacture. And it's actually part shortage, all types of supplier shortage. What that's done is Porsche, part of the Volkswagen group, has had to stop production of the Porsche Taycan, their play at an electric Porsche, because the wiring harnesses are made in the Ukraine, and the wiring harnesses are disrupted. The supply chain is disrupted by the conflict with Russia. Volkswagen works on a 9-year budget, 9 years. So when their supplier is disrupted in the Ukraine, they have to have a board level decision on will they create their own in-house wiring harness manufacturing. So supply chain has stopped production of the Porsche Taycan. And this type of activity is happening for every manufacturing company globally right now. Tesla has increased production during these shortages. In fact, they are the only car company on planet Earth that has increased production during these supply chain shortages. Why? In Tesla, there is no budget. There is no budget. When your wiring harness supplier says we can't make wiring harnesses, you do not have to ask for budget to go to a different supplier. You simply go to a different supplier or start making it in-house. You order a robot today that you think could help you make this thing in your own facility. You just order it. You don't ask anybody. You just order it. Everybody can see that you did it. There's what's called digital self-management. There's these monitors everywhere that shows where money is being spent. You don't ask, you make it visible. If someone thinks it's really bad, they will run over and talk to you and work with you. They'll join your mob. No one tells you what to do. You are actually autonomous. And there are over 100,000 people doing this. So you have real-time finances. How much money is in the Tesla bank account now? That has replaced budgeting. So from the moment you're hired, your phone tells you, here's how much money the company has. Spend it as fast as you efficiently can. So when Tesla, the chip that controls the electric seat adjust in all the Teslas, when that supplier was disrupted, you could not buy that approved circuit board anymore. Engineers in Tesla ordered similar chips that day and started making their own chips. Their own chips arrived in about 3 months. They had different chips later that week. Meanwhile, the same people that were ordering the chips started writing embedded programming, trying to learn how to write embedded programming so the new chips would run with their seat controls to adjust the seats forward, backwards, up, down. In 2 weeks, they had a new chip in production with new software. No other car company on planet Earth operates at those speeds right now. Their supplier cycle is dictated by a set of meetings with a coalition. And the coalitions in many cases meet every 6 months. So they have what are called plant shutdowns, where they wait for the right materials, the approved materials. There are no approved materials in Tesla. It's what is in the car now. And what matters here, the question is, what's important for hardware agility and quick feedback loops when it comes to suppliers? What's important is that you don't have any cadence waiting for you for approvals. You can go act now. That then creates a relationship with your supplier where they try to respond more quickly. If you work with your supplier on 1-year contracts, suppliers like that, they now can invest in you. They know they have money coming from you for a year. Most suppliers don't want a 1-day contract. They can't invest in you. They can't set up robots just for you. It's not financially efficient. So what Tesla does is they make contracts with suppliers for 1 year, 2 year, 3 year, 5 years, but they say every 1 week we may ask for you to make something different. So there's an investment with the supplier. They know they're going to get a year's worth of work from Tesla, maybe 5 years worth of work from Tesla. but what they're going to be doing can change every 1 week. Once the supplier is able to perform at that level, they're asked to work on no cadence. They might get a call anytime requesting to change production type. And that actually works very well. Tesla does that even for very large products, like the biggest products you would buy from a supplier, which are the stamp and die sets. They're car-sized metal sandwiches that press sheet metal into shapes. And they come in series. So you typically have 10 or more of these that press car panels or inject car panels. Those are also changed every 45 minutes. Let me do an audio check before I do more questions. How's the audio coming through?
Pretty good. Yeah. We hear you loud and clear.
Thank you. Thank you very much. Okay, good. To create a full product, you will likely need both software and hardware in a producing company. How do you marry the different pace of software and hardware development? Hardware and software are both made multiple times a day. Now it's hard to explain unless you've seen it, but first, facts. In Tesla, there are 60 new hardware parts introduced every day. Every day. Those are electronics, those are airbags, those are seats, those are different shaped pieces of metal, plastics, every day. Now, let's compare that to Volvo. Volvo, like most car companies, has a 2.5-year minor model change cycle, where small numbers of parts changes happen every 2.5 years. And depending on the model, every 5 to 10 years is a major model change where most of the parts are changed. This is normal. So now you have a cadence. You have a cadence of part introduction every 2.5 years for a few parts and every 5 to 10 years for a lot of parts. Now, software in some of these companies can change faster, maybe once a year. So those don't line up. This is not the case in agile companies like Tesla. Agile means you introduce product all the time. There are 60 part changes a day in Tesla. So of course it makes sense for software to be deployed anytime. In Tesla, software in practice is deployed about every 2 weeks. Internally, there's new software every day on cars that are being manufactured and tested and on test vehicles. So that's multiple times a day. In some cases, multiple times a minute. New software builds are released in-house. To the customer, new software is pushed to all cars about every 2 weeks. So actually, software is slower than hardware in Tesla. Hardware changes multiple times an hour. Yes, if you look at almost any other car company in the world, you have a 2.5-year cadence for hardware, for some hardware, and a longer cadence for more hardware, and you have a 1-year cadence for software. So these cadences don't match. What I'll say is that is a failed agile implementation. That's like what we thought agile was 15 years ago. So a modern agile implementation is real-time introduction of hardware and software, and then there is no difference in cadence. In order to manufacture hardware that quickly, you don't do annual budgeting. Budgeting becomes real time. You don't do traditional management. Management historically was annual performance reviews. Well, instead you would have real-time performance reviews. Every day you have real-time performance metrics for each project. You're not as much worried about what people are doing. You're more worried about the rate of advancement in your projects. It's not so much about managing people as improving the product as fast as possible. So in Tesla, there's very little attention to who is doing what or how good they are or not. In fact, you almost don't care. It's, are the products maturing rapidly? Is quality high? Is customer visible value increasing? So those are measured in real time, daily. What are the best practices and the no takers while implementing Agile in hardware development? Reducing cost to change is the fundamental enabler of hardware development. So if you have an approved supplier that has a 1-year lead time, that is your bottleneck. And you would begin negotiating with that supplier to try to get a 3-month lead time. Or you'd start looking for other suppliers, or maybe even bring that part in-house. So you look wherever is your longest lead time and you mob on that. You do collaborative engineering on that, collaborative procurement. I started this session by saying all work in Tesla is done as a group in doing mob or ensemble. And it is tiring. It's also extremely fast. So working with procurement, you might have 3 or 5 people sending emails and on the phone and texting. We prefer text because it's so fast. iMessage mostly, but sometimes Signal. Messaging, emailing, and on the phone with suppliers. One person is doing that. And then about every 7 minutes, we rotate who that person is. So someone fresh is always in the role, but those other 2 or 4 people were listening the whole time. So they can engage immediately. They're not doing something else. They're actually waiting. And they're quietly giving tips. They're writing notes saying, make sure you ask about this. Or they're whispering, oh, you forgot to mention we need to change the steel alloy. This keeps quality super high. It's very tiring to have 3 people or 5 people work on one thing at once. The speed is incredibly high. A supplier issue that might take 2 weeks of negotiation is often done in less than 10 minutes. What supports this is Elon Musk refuses to sign any contract that's more than 1 page long and not written in plain English. If there's any legal terms like notwithstanding herefore which, that document is immediately thrown out. And Tesla supplies a plain language equivalent. If the supplier won't sign it, Tesla won't sign it. So there are no documents that are longer than 1 page. That makes supplier renegotiation really easy for anyone. And there is no legal review except to simplify the document to make sure it's plain language readable. So you don't have to wait on legal review. So for hardware development, you're attacking the bottleneck to make shorter and shorter lead times. The engineering practices, the physical manufacturing practices, are something that I've become a little bit famous for. That's called extreme manufacturing. Chapter 10 of my book is all of the extreme manufacturing principles, or XM principles. So if some of you are interested in how do you actually engineer that fast, how do you build that fast, that's the extreme manufacturing part. What I'm talking about now is more management. How do you not have your contract waiting in legal review? Well, legal enforces the contract is written in plain language in 1 page, so you don't need a legal review. Then the next bottleneck is typically approvals, certification, homologation. Most governments take about a year to review a new product, especially something like a car or an airplane. So how do you get that review to be every day? You negotiate with the government entity and ask, what do you need? The goal is not to change your approver. The goal is not to change the government entity. The goal is to give them everything they wish they had instantly for you to become agile. So the government entity often has a list of 100 questions that they really need to know the answer to know that your product is safe and appropriate for use. Well, if you have already answered all those questions in a very clear way, it doesn't take a year. The certification and approval can take 10 minutes. And that's what Tesla did. They said, what are the questions that you have to understand to approve this car legally? And what they did is they automated every car to put itself through that test. So the cars do something called factory mode. Every car, the moment it's assembled, puts itself through every required road legal test: anti-theft prevention, corrosion resistance, accident avoidance, and then also comfort tests like noise, vibration, and harshness, handling tests. So there's tests customers want, there's tests Tesla want, but highest priority, tests the governments want. European Union governments, United States governments, Canada governments, Japan government. What are the tests they want? The cars do those themselves, every car. It's very important that every car puts itself through these tests, because if you test 1 out of 1,000 cars, then that means you can't introduce change until 1,000 cars from now. Now you have a change cadence, and you have to wait for the next cadence to introduce change. That means you have to know where you are in the cadence. That's waste. That's 100% waste. If every single car tests itself, you don't have to know what the cadence is. You don't even have to ask. You know, this car, this individual car will test itself, so I can make change to it. I can introduce a new airbag to it. I can introduce new software to it. I know this car will test itself. And if it passes road legal testing, we will sell it, even if it is the only car of this specification. Now you have agility. Agility means you don't have groups of testing. This is why Scrum is a very old form of Agile. I don't know how many of you are Agilists. Scrum has a cadence. It has something called a sprint, and you do withhold change until the next sprint. Scrum actually works great for companies that have a year or longer budget, and they're trying to get Agile. But Scrum would never keep up with what modern Agile companies like Tesla are doing. They have no cadence, they have no sprint, they have no rhythm. Every product must test itself. For those of you who are familiar, that's what we call CI/CD, continuous integration, continuous deployment. When you have CI/CD, it means every car tests itself, fully road legal homologated, and your rate of new product introduction is dictated by how fast you can test them. Test in hardware and software becomes the gating limiting factor. This is why autonomous testing is a first-class product. It's a highly funded project in these companies, so you can reduce the rate to introduce product. Take concept development, industrialization, procurement, manufacturing, and operations. How would you organize these parts on a high level? What are key here? Oh, awesome. Okay, so let's say you want to make a seat, an automotive seat, and it has electronics inside, it has airbags that fire, it has comfort requirements, it has longevity requirements, it has stain resistance. Like say you're wearing blue jeans, those shouldn't color your seats. The seats also shouldn't color your white pants, even if it's hot. If you spill coffee on the seats, it should be easy clean. So you have many types of requirements for seats. Well, what you start with is a bunch of test fixtures to autonomously test a seat. So you have odor testers, electronic odor testers, to say, is odor being released from the seat? Is there a glue smell that the customers might not like? If you've ground coffee into the seat, does the seat still smell like coffee? Or when it was cleaned, does it not smell anymore? So you get an electronic nose, an olfactory sensor. You haven't designed a seat yet. You have a digital smell tester, but no seat. Then you have pressure sensors, and it looks like spider legs. They have pressure sensors, and it says, is there any part of this seat that is higher pressure? What you want is uniform pressure throughout the entire seat. And it tests the back, the headrest, the shoulders, the hips, the thighs. So you have a pressure tester. And that pressure tester is able to test any shape of seat. It's not for just one shape. So now you have a pressure tester, but you still don't have a seat. Then you have airbag testers with dummies. And you have software testers to simulate airbag testers as well, because you can't detonate every airbag. But you have physical testing for airbags, and then you have three-dimensional scanners to then make digital models of the 3D testing of the airbags. Now you can test simulation of the airbags. You're building up your test suite so that if you got a seat, you would know, is this road legal? Is it stain resistant? Is it comfortable? You would know all of that autonomously in the shortest amount of time possible. Now, in real life, what this means is your tests start with taking like a month to run, and you have a team or teams of people who are setting up these tests, measuring the results, entering the results in spreadsheets. I mean, that's how it begins. But that project never stops. You have a constant funding rate. It's not a phase, it's a constant funding rate to test. So testing continues to get faster and faster forever. You're adding automation, you're adding faster testing, higher quality testing. It never stops. It's not a one-time funded activity to test. So you start with testing that takes about a month, but your goal is for that testing to get down to less than 5 seconds. You put a entirely new seat into this range of test fixtures, and in less than 5 seconds, ideally, you know, is this safe, road legal, good to put in a car? Red light, green light. That's what you want. Now you start engineering seats. Now you start drawing pictures of seats, you start drawing 3D models of seats, you start trying to make seats, you start buying fabrics, you start seeing what fabric can we get today. There is no interest in making a long lead relationship with a fabric supplier. You could use a totally different fabric in 10 minutes because now you can test these things very quickly. Now you have agility. So you have a designing group that is working next to these test fixtures. And there is no difference between prototyping and production. They might make one of a new seat design, just one. But if it passes all tests, it's sold. And if it's better than what we were making, that same group of designers then starts working on how to make 10 of these an hour, 100 of these an hour, 1,000 of these an hour. They do what's called the production ramp. And they'll ask other people, okay, we're doing the production ramp, who can help? Actually, they ask through apps. They'll yell it out too, but the factories are really loud. So design happens in the factory. Testing happens in the factory. There's not some separate beautiful office for design. It is all in the factory. And design is the same as production. Design means adjusting the production machinery to change the design. And if you're doing 3D design, in most companies, that's in a separate country, in a separate office. And even more broken mind than that, in most companies, the attractive jobs like 3D design are in high paid, nice countries. And the less desirable jobs like production are in lower paid countries. I mean, this is basically global corruption. So if you put all these into the factory, you also get a more equitable workplace. And of course you get less complaints because people are treated more fairly. It's a more egalitarian production method. Okay, so that was about development, industrialization, procurement, manufacturing. Is basically it's one mob on the means of test. And you build back the means of production once you have the means of test. And you never stop improving the means of test because that is fundamentally your bottleneck. And that's how you get to 60 part changes a day. I mean, the seats alone change more than once every single day. And it's because of how I just described that. Whereas most companies, you would negotiate with leadership for annual budget that might include a seat change. And that seat change would be sent out to a supplier anyway. So you'd negotiate with Lear or Johnson Controls and or Bros or Bosch and say, we want this seat for the next 7 years. And they'd have a 3-year negotiation and development process for their seat. And what they'd end up selling you is a version, a tweak to a seat they already make anyway. So you don't even get breakthrough innovation. So your seat part change is like 7 years. I mean, maybe you can get a custom color fabric, but even that goes through a multi-year like wash and test cycle, because the testing is not automated. It's like medieval. It's ancient, and people think that's normal. It actually boggles my mind that people think that's tolerable. Okay. How long turnaround time does Tesla have for significant hardware changes like seats or top hat changes from idea to market? Okay, this really depends, because speed of creativity is the unknown. How long does it take for someone to have a new good idea? No idea. Humans are the creative part, and we need to get inspired. But from the point someone has a good idea and they can draw it in CAD, it can take less than a day for that new part to be in production. In some cases, it can take 3 hours. But when will someone have an idea for a better seatbelt? No idea. That's completely unpredictable. So the rate of innovation, that's a human factor, and we don't know. But from the time a human has a clear idea to try, the automation, the agility can make that very fast. For example, the headlights, taillights, and electric charge port on the Model S and Model X were both changed in production from idea to done in production in 2 days, 48 hours. That's very normal. But how long did it take for people to have an idea of this better headlight, better taillight, better charge port? No idea when that's going to happen. So you can't budget for that in advance. You can't say next year we're going to do new headlights, because we don't know who's going to have a great idea next year. The idea is, as soon as someone has an idea, they have the ability to execute it immediately. But I will say, once that happens, 3 hours is very reasonable. 48 hours for headlights, taillights, and charge port that's historic fact. Okay. Is it true that the toilets were placed far away? Yeah, yes. That is actually that is actually my biggest problem with working in Tesla, is how far away the toilets are. And there's actually portable toilets everywhere for to help address this problem. What happened is Toyota had a huge factory in California, in the Los Angeles area. And before that, it was owned by General Motors. It was the worst performing factory General Motors had, a huge facility. And General Motors sold it to Toyota. And Toyota replaced all the management, kept all the employees, and it became the highest performing facility in North America. And that was a famous event, that Toyota could just change the process and management style, and the productivity went way up. Same employees, mostly same machinery, same building. Well, Toyota couldn't make a profit in that building. They were losing money constantly. So they sold the building to Elon Musk. Elon Musk bought it for like, I don't remember the dollar figure, a very low amount, this huge factory. Toyota took all the equipment, and you basically had this huge cement box that was designed for single one-piece continuous flow. That's normal. This is how most manufacturing happens around the world. Single one-piece continuous flow means you decide what you're going to make in advance. You plan the manufacturing steps in basically a big line, and it weaves around like a snake through the facility. And one step feeds the next. The problem with that is, if you introduce a change at any one step, you have to adjust every downstream step. It's the slowest to change. It's extremely efficient to make the same thing as long as you never have to change. And this is why during Supply chain disruption, most manufacturers are having a hard time. They have single one-piece continuous flow. Well, Tesla doesn't do that. Instead, they have agile cells. You don't look at the factory from above like a line. You look at it above like a game board, like a game of Risk or Carcassonne, where you have all these hexagon tiles. Each hexagon produces something and it can deliver in any direction. So you might have seats here. You might also have seats here. And those are delivered by autonomous carts or humans pulling carts to anywhere they need to go. There is no line. What this does is your inputs and outputs at any given point can change multiple times a day easily. It's not a big issue. If your inputs and outputs changed in line production, you'd have to change the line. Well, that's way too slow. Okay, so now you have a problem. Tesla bought a factory that was built, this big cement box, huge, that was optimized for a line flowing through it. And now Tesla looks at it, it's actually three-dimensional. Your hexagons actually also deliver up and down and at an angle. So you actually have 3 dimensions of delivery. So you have these three-dimensional, I don't know what you call a three-dimensional hexagon, but that, I mean, you can think of it like a cube. That's not far off, but you deliver on the angle as well. And you stack, you actually measure the factory by the cubic meter. The floor plan doesn't match. So where do you put the bathrooms now? You used to have these bathrooms on a set distance from these assembly lines, but now you don't have assembly lines. And the pipes for the bathrooms are poured into the concrete. So how do you put bathrooms near anyone anymore? I mean, you have people working on catwalks, you know, suspended metal, like 10 meters off the ground to deliver down and deliver up and at angles. There's no bathroom there, right? So what do you do? So what they've done is put portable bathrooms near all these spots, and they have agile teams that change these bathrooms and actually keep them smelling very nice. The problem is, what do you do if you're in paint? And I spent a lot of time in paint and coatings because that was the fundamental bottleneck while I was operating Agile at Tesla. And in paint, you wear a bodysuit and you can't wear cologne or deodorant because it reacts to the chemical reaction of the paint as it's curing. It makes different types of imperfections in the paint. So you can't wear cologne, most cologne. You can't wear deodorant, most deodorant. You actually can't use most kinds of shampoo. You wear nets over any hair and you have a bodysuit on. Well, you have to go to a very special bathroom to avoid contamination. And that's a big, complex, non-portable thing. And there's no place to put it anywhere near the paint robots, the paint mixing stations. So you're mixing your own paint. You're actually a chemist. This is different than most companies where they just order paints. You're changing chemistry multiple times a day. You're changing robot spray heads, and the robots wear clothes, actually, anti-contamination clothes. You're changing what types of clothes the robots wear and their spray heads multiple times a day. You're changing the paint paths because there's a never-ending pursuit of superior paint. Not to mention, you're getting new parts, different shaped parts to be painted multiple times a day. So the robots are encountering things they've never seen before, multiple times a day. And you have to help the robots accommodate that. And also there is some manual painting or defect remediation, etc. So you're in this protected paint suit and your special bathroom is nowhere near you because there's no place to put it anywhere near you. According to California labor law, you have a 15-minute break every 2.5 hours, I think it was. Well, the bathroom's 7 minutes away. So you're running in this hot suit and you want to get a coffee because you're tired. I mean, you are working 12-hour shifts. So you're running and you're like, I wish I could get a coffee. I have a choice. I can either go to the bathroom or I can get a coffee, but I'm already hot. So do I really want a coffee? I want caffeine, but do I want coffee? And it is miserable. Now, this has been addressed in Giga Berlin. This has been addressed in Giga Texas because they built those buildings themselves. So the right bathrooms are right where you want them. But in this legacy building bought from Toyota, which they bought from GM, Yeah, the nice bathrooms for paint are nowhere near you, and that really is a problem. Yeah. What do you think are the most important changes when it comes to working with hardware that traditional car companies need to succeed in the future? I do think the first fundamental change is budgeting. The idea of a yearly or longer budgeting cycle has to change. We have to move to at least quarterly budgets, but really the goal is real-time budgeting. Once that has happened, then the agile engineering, production, and supply chain management practices make sense. But imagine if you get agile supply chain practices like lean agile procurement, which is awesome. Mirko Kleiner has done phenomenal work with lean agile procurement as a discipline. He's based in Switzerland, so it's very easy for Mirko to come visit Gothenburg. Imagine if you get great lean agile procurement and you can change contracts and your suppliers like it. They like the way these contracts change. You can do it once a day. But imagine you have an annual budget. It wouldn't matter. It wouldn't matter if you could change contracts once a day and your suppliers loved it because you're on an annual budget. There's no money to fund the supplier differently. So none of these agile engineering, procurement, management practices make sense until the budget cycle is faster. This is fundamental. I'd say that comes first. I'm super proud of my work making extreme manufacturing, the engineering and manufacturing practices for agility. They're not helpful until the budget cycle is fast. So fundamentally, that's a change first. With a decentralized decision-making strategy, how do you make sure that these decisions align with the direction of the whole company? It's so easy. I don't think most people would believe me. So I'll say what it is. How do you keep common direction when you have decentralized management, when you have self-management? How it is Twitter. I mean, that's it. The centralized goal is Twitter. So what happens is Elon Musk says the goal of SpaceX is to spread the light of consciousness out among the stars. Now that's a very intentional word choice because that can mean get humans living on Mars or beyond, but it can also mean artificial intelligence. The light of consciousness doesn't have to be human. It could be cats. Let's get cats living in other solar systems. Like, in fact, I bet that will happen at some point. But the goal is spread the light of consciousness out among the stars. Truly, that is so clear that everyone manages autonomously. You don't have to ask Elon for anything. You know the goal of the company and you know how much money is in the bank account. So your goal is to spend that money as fast as you efficiently can towards the goal yourself. So there's no budgeting meetings. You don't wait on budget. For Tesla, the first goal is accelerate the world's transition to sustainable energy. If you can build a solar panel that's faster, cheaper, lighter, in higher volume than before, that is an instantly approved project. There's no approval. I mean, do it now, right? Twitter. Elon Musk calls it the master plan. It works really well. It's never longer than one page. And as soon as one is achieved, Elon writes the next one. And if you're doing any work that's not aligned with the master plan, you know you are doing something wrong and you should stop immediately. And no one has to tell you, you know. Now, this is so simple a concept. I'm not sure if anyone in the audience would believe me, but that's it. Elon tweets the master plan. There's not a town hall meeting. There's not an email. He tweets the master plan, and you check yourself. Am I working in the most efficient way towards the master plan? And that is it. When you've been at more traditional car companies, do you think they stand a chance to be successful in the future? I'm lucky enough to have been in Volvo. I'm lucky enough to have been in MAN Truck and Bus. I'm lucky enough to have been in John Deere, agricultural machinery, in Europe, in South America, in North America, in Asia. I'm lucky enough to have worked with Ford, with Bosch, with Bros. I worked in Toyota before. I've gotten to see a lot. And I'll say, I have never, ever seen change as fast as in a Musk company. Nowhere near. Nothing. I've never seen anything as fast as in a Musk company. It's truly like looking at a tree grow and looking at a cheetah run. I mean, it's different. So the question was, do more traditional companies stand a chance? Yes. Yes, but I think the operating model, the operating presupposition that we can plan a project 9 years from now, Volkswagen is on 9-year budgets. The idea that you can plan your product mix 9 years in advance, that is not compatible with moving at the speed I'm talking about. So there are some fundamental mindset shifts that would have to happen, which we Agilists call the Agile mindset, which is a confidence with test and learn. So that means you have very robust, fast executing tests. So suddenly funding tests is a massive line item. A huge percent of your budget goes to funding tests. That's different. For most companies, tests are an expense, and they try to reduce that expense, even if it means testing less frequently, or reducing the quality of test, or outsourcing test. Like test is something someone else could do for you. Like you have these broken minds. Unless those change, no, these companies are all dead, truly dead. The only way they could stay alive is with massive government support, but they'd be making an antiquated product their customers won't love. And it'd be a depressing job. So no, those companies cannot survive without a massive mindset shift. And it's obviously true already. Tesla, for example, by market capitalization, by total company value, is worth more again than every other car company on planet Earth added together. This method has already won. And the next master plan is to grow that by 10 times. If that's successful and Tesla has met every master plan so far, that would mean Tesla would be a $10 trillion US company. No, those other companies do not stand a chance unless they fundamentally rethink their speed of delivery, their speed of response. How are Tesla working with spare parts? Backwards compatibility. So the goal is to introduce new parts as fast as you can without increasing total part count. That includes all parts being supported. So if you make a new part, it replaces the previous part and you no longer stock, you no longer carry the old part. So if a customer has a part failure, they get the new part. You don't continue servicing the old part, you replace it. Backwards compatibility. So when the new headlights and taillights came out, they got an adapter so that they can replace the previous headlights and taillights. You don't carry the old headlights and taillights anymore. That increases the number of total supported parts. This is why the exterior of the new Model S, that's the sedan, the large car Tesla makes, is almost identical to the first one they made. The parts are completely different, but the car looks really similar. So you have backwards compatibility. You have adapters and backwards compatibility. There are 60 new parts introduced every day. There are more than 60 parts eliminated every day. The total number of supported parts actually decreases every single day. That's the goal of maintenance, backwards compatibility. How is homologation done at Tesla? Homologation is autonomous. That's what's called factory mode. Every car puts itself through every homologation test that is non-destructive. The destructive homologation tests, like impact tests, those are simulated. And 1 out of every N cars, I'm not allowed to say how many the N, but let's say like 1,000. One out of like 1,000 cars is impact tested, many different angles, many different ways. That impact test is used to update the software. The impact test is not sent to homologation ever. Only simulation is sent to homologation. The impact tests are done to check, are the simulations still accurate? Every car simulates itself through the destructive tests and physically performs all of the non-destructive tests like theft prevention, like water penetration testing. Those results are sent on a one-page digital document saying, here is how this car, here's how I, this car, am different from the last car, because every car is potentially unique. Here's how I am different than the last car. That one-page document is only what's different. That is sent to the homologation authorities, and that car is individually certified for production. So homologation is on a per car basis. It happens many times a day, every single car. And because every question the certifying bodies ask is what is in that form and nothing else, it's now very easy to approve. The approvals are almost automatic, but they are actually performed by the government agencies in Europe and in the USA and in South America and in Japan, etc. How do you ensure quality when moving so fast? Okay. Quality is determined by autonomous tests. And the faster your autonomous tests, the faster you can ensure quality. So imagine you have car paint. And one way to check quality on car paint is you have a master painter look at the car from different angles with different lights. They hold up a mirror. They might even rub a clay bar on part of the car, hold up a mirror and have lights. And it takes them a certain amount of time per car. That's one way. In fact, if they check every millimeter of that car, it might take them all day. That's one way. Imagine if you have high definition cameras measuring each photon of light that refracts off the car. And you measure what is the frequency of light, so your color. What's the frequency of light in photons that comes back? How many photons come back is called luster. Luster. So how many photons of that frequency of light come back is luster. How many photons of different frequencies of light come back is poor paint quality. You're not getting the color hue you want. Your accuracy is low. Then what you also want is if the light is coming this way, you want really low refraction this way. Very few photons coming back this way. This gives you depth. As you move your eye across the car, you get very different intensity of light back. That's high quality paint. Well, those cameras can measure each individual photon of light as they go across the car in about 1 second. And the software stack that checks how many photons of light at what angle are coming back is more accurate than that master painter who took all day. And now you can check that car's paint quality at a higher level, a more accurate, a more repeatable level in less than 1 second. That is how you ensure quality so fast, for example, in paint. This is true for every step in the system. You say, what is incredibly high quality? How quickly can I test to that level? So there's a fundamental misconception that you can't go fast and have high quality. No, that just means your testing process is slow and inconsistent. If you need a long time to test, that means you need to better fund your test cycle. Okay, my apologies. I'm actually at the next appointment.
Yeah, so we're so happy that you could join us. Thank you so much, Joe.
It is my honor. Thank you very much. You can tweet at me if you have a different comment or question. I have a near 100% response rate on Twitter. Thank you so much. I hope to see everybody in Gothenburg before too long. It would be my honor. I'm grateful to collaborate. Thank you.
Take care. Have a good day.